In this course, we will explore 3 different types of the first-order differential equation. Differential equation of separable variables, homogeneous differential equation, linear differential equation with integrating factor. In this video, we will explore how to solve a linear differential equation with integrating factor. What's the pattern of linear differential equation with integrating factor? This is the pattern of the equation. dy dx plus p of x times y equals q of x. This is given in the formula booklet. Integrating factor for linear differential equation is e to the integral of p of x dx. Normally for integrating factor, I will use I stand for it. E to the integral p of x dx. Let's take derivative of both sides. I prime equals E integral p of x dx. According to the chain rule, we will do integral p of x dx prime. E to the integral p of x dx power is I times. We take derivative of integral, we will get p of x. So I prime equals I times p of x. Let's go to this linear differential equation. Y prime plus p of x y equals q of x times I both sides. I times p of x is I prime. We do know uv prime equals u prime v plus uv prime. Basically, this is the product rule of derivative. I y prime equals I q of x. Integral both sides. We will get I equals integral I q of x dx. If possible, please remember this formula. Here are the steps for solving linear differential equation with integrating factor. Check the pattern of the differential equation. Find the p of x and the q of x. Make sure p and q are the functions of x only. Find the integrating factor. I equals this without c. Use Iy equals integral of I times q of x dx to solve for y. For a, dy dx minus y times tangent x equals cosine x. It's given that y of 0 equals 1. X is in the first quadrant. We check the pattern first. It's exactly this pattern. P of x equals negative tangent x. Q of x equals cosine x. Then I equals e to the integral p of x dx. We work on integral p of x dx separately. So we get integral negative tangent x dx. This equals integral negative sine x over cosine x dx. Since cosine x prime equals negative sine x, so we get negative sine x over cosine x dx. We can use a special formula, integral f prime of x over f of x dx equals natural log of absolute value of f of x plus c. So we get the natural log of absolute value of cosine x. Since x is in the first quadrant, it equals natural log of cosine x. Let's go over some formula for logarithm. E to the n times the natural log of x. We will make this n as exponents first, then equals x to the nth power. We got to use this formula for solving linear differential equation a lot. So we get e times the natural log of cosine x. This equals cosine x. Then second step, I will use this formula. Iy equals integral I times the q of x dx. I is the cosine x. Y times cosine x equals integral I is cosine x times the q of x is cosine x dx equals integral cosine square x dx. For cosine square x and sine square x, we got to use a double angle formula. Since cosine 2x equals 1 minus 2 sine square x, also equals 2 cosine square x minus 1. So we get sine square x equals 1 minus cosine 2x over 2. Cosine square x equals 1 plus cosine 2x over 2. 1 over 2 plus 1 over 2 cosine 2x dx. Work this out. 1/2 x plus 1/2 sine 2x times 1 over 2 plus c. Organize 1/2 x plus 1 over 4 sine 2x plus c. On the left side of equation is y times cosine x. We will use a boundary condition to figure out this c. Since y of 0 equals 1, then we do the substitution for x and y. 1 equals 0 plus 0 plus c. So C equals 1. Then we plug back over here. Y cosine x equals 1/2 x plus 1/4 sine 2x plus 1. Then divided by cosine x both sides. Reduce y equals 1/2 cosine x times x. Then plus sine 2x is 2 sine x cosine x. Reduce. One half sine x. Then plus 1 over cosine x. You can leave as it is, or we do know 1 over cosine x equals secant x. So we can do 1/2x secant x plus 1/2 sine x plus secant x. This is the final solution to A.